So John has been a GIS analyst with the North Carolina Office of Risk Mapping for 14 years. His projects include the Integrated Risk Program, Spatial Data Download, and the new statewide QL1, QL2 LiDAR collection. Before working for the state, he spent 9 years in the private sector as a photogrammetrist with the GIS LiDAR and GIS LiDAR specialist. Thank you, John.
Thank you. Hello, good morning. I hope everybody's had a good night last night. So today I'm going to talk to you about flood inundation boundaries using the Atlas 14 recurrence interval information from NOAA. So, and the reason we're going to talk about this is because the two main questions that we get asked at NCEM after any rain event is, number one, where is it going to flood? Number two, how many of our structures are going to be damaged? And it's all great after the event has gone, it passes by, we can send out engineers and do our high water studies to track where the water actually was after the fact. But people want to know when it's happening. And that becomes a little bit more problematic. So this is a slosh layer provided by NOAA, the National Weather Service. And it can give us a general boundary of slosh inundation. And this is released usually every 6 hours during a hurricane event. And with that, we can see the edge of where we expect water to be. But this is slosh inundation. So this is just on the coast, and this is where wind and high water pressure and tidal information is pushing that water onto shore. It's not actually showing us anything inland. But it is still very useful because we can tell how many structures are going to be inundated. Now we can't tell we cannot tell you how many structures are damaged at this point. We can tell you how many are going to be affected because of the slosh inundation boundaries. We have first floor elevations for the majority of our, well, we have first floor elevations for all of our structures in the state of North Carolina. The state of North Carolina has a structure footprint data set that has 5.2 million records in it that is maintained, well, it's owned by NCEM, and it is freely available. If anybody in this room wants a copy of it, feel free to go to our spatial data download site and download portions of it. Go to NC1 map, download portions of the building footprint data set, or you can email me directly and I will send you the entire thing or just your county, whatever you need. But with the first floor elevation, we can determine with the inundation layer that tells us how deep the water is going to be, whether or not the structure is going to be flooded. All right. So as I was saying, so we were looking at the slosh inundation where it came, we got to Gates, we got to Chewan, Washington, Beaufort, but this is from Matthew, I think. Yes, this is from Matthew. And these are areas where the historical record was exceeded for Matthew. We have no inundation here. How are we going to tell people prior to the flood, just by looking at forecasts, whether or not they're in danger of flooding? What we did for Matthew, what some of these contractors that are sitting in the room did for Matthew actually, was they looked at the hurricane flight path, or the wind path, and then they looked at the 24-hour or 48-hour precipitation forecast, and they literally went to our Feynman gauge site, our Feynman site, and manually looked up the gauge results for those specific areas and said, well, we're getting this much rain in Durham County. I think that is going to be a 100-year flood event. And so for each county that was affected by the wind swath, they went through and clipped out the flood boundaries that the flood study boundaries that we have for floodplain mapping. Well, for the next storm, because that was a lot of labor intensive work, they decided to use the Atlas 14 data set. So they said we have 14, we are expecting 14 inches of rain in this particular area. Let's go to our Atlas 14 data set, and we can tag the county in the area and see what the recurrence interval is for the Atlas 14. And this is what the result was. So you get this map that says, I've got part of the area that's 100 to 200 year. We got part of the area that is 600 year. And what they decided to do was just, the entire county is a 200 to 500 year event. Let's use that floodplain boundary. And then we can start mapping and predicting how many buildings are going to be damaged and what those damages might be, so that we can send them out to get a declaration from FEMA. And this would be an example of, they just clipped the boundary, the floodplain boundary to the county, and then ran numbers to estimate, the number of flooded buildings and their potential damages. That was all complicated, and it took a very long time to do. We would generally only get one of these inundation boundaries a day, maybe two a day. So one of our very clever engineers decided that he was going to write a script that would automatically do this. And it worked very well. And they used it for Florence. But then I decided that I was going to take that information and refine it a little bit and make it a little bit better. And make it a little bit more localized than an entire county. And so what the tool does is it downloads the precipitation information. And because forecast precipitation information is in a shape file, you have to first convert it into a raster. Because what we're going to be doing is we're going to be taking points in a grid and assigning values to each of those points. So the floodplain, or not the floodplain, the precipitation boundaries or areas rasterized, then turned into a grid. So now we have a grid. I don't remember what the grid is. I think it's 90 because it was set up to match the NOAA slosh inundation boundary grid cell size. So now we can, for each one of these cells, we know exactly what the inundation interval, the recurrence interval, is going to be. And if you take that and simplify it so that you have not 1,000 polygons, you have just a couple, you can clip out the floodplain boundaries to those polygons. So now, instead of the entire state of, not the entire state, the entire county of Durham, if only 50% of that is in a 100-year and the other 50% is in a 50-year, you're not overestimating the damages and the inundation boundaries to the entire county by making that entire county a 100-year event. And then you can re-rasterize, so you can get a water surface elevation to run your damages. This one always throws me because it's the reservoir. But real life results. All right. So this is all well and good, but does it work? And fortunately, knock wood, we haven't had a severe rainstorm to test it with just yet. The closest one being Thunderstorm Fred. And what we found is it actually does pretty good. So this is water surface elevation. The teardrop markers are actually previously mitigated buyout properties that they wanted to verify, their dollars spent, that they actually did what they were supposed to do. And you can see they actually would have been affected by this particular storm had they not been bought out. But you can also see the green, maybe. That is a high water mark right on the edge of our boundary, of our predicted boundary. And again, these are all high water marks. And you can see that they follow really closely to the edges of
John, we can't hear you.
to the edges of our predicted boundary. The red dots or the red teardrops. And I love this example. This was actually just kind of accidental. I wanted to give you a better example of what everything looked like, and I got this awesome picture. So the yellow markers are the high water marks, but you can see we have 3 different inundation recurrence intervals. So this particular section is a, what is it, 25 to 50 year. Then we have the 10 to 25 year, and then we have what is it, the 5 to 10 year. So instead of making that entire area a 100-year event, we have parts of the area that are only a 5-year event. But if you look at our high water marks, that's actually kind of accurate, being that these cell sizes are huge. And they're not going to be as refined as if it were, something smaller. All right, and that is all I have for you today. I do want to say that this tool, I have packaged it up as an Arc Pro project template. If you guys want it, you can have it. It is public information. I won't say it's the most elegantly written script, but it does work. Just give me an email, john.lay@ncdps.gov. I will be happy to send it to you. I think it is about 300 meg, so be prepared for that. And it contains all the information that you would need to run these analysis. So the whole process takes maybe, oh, I'm sorry. The question was, how long does it take to run the Polygon to raster? Being that the raster cell size is 90 to 100 feet, not that long. The entire process for the whole QPF inundation lasts maybe 20 minutes. Sometimes up to 40, depending on how temperamental ARC is being at the moment. The tool actually does a QPE, which is the observed precipitation. So you can go back and check your forecasts. I will say that one of the caveat to that is NOAA doesn't maintain the data for very long. So they will hold the forecast for a couple of days, and they will hold the observed information for a couple of weeks. Anybody else? Yes, Ms. Hope. How often do you download the QPF? Well, it is per tool usage. So it happens as so if you are you're doing a forecast, you will select the interval that you're looking at. If it's 1 day rain event or a 2-day rain event, and then you will select what you want to compare that to as far as the somewhat helpful. Oh, gotcha. Depending on what the interval that you're looking at. So you want to, if you're doing a two-day event, you want to use the Atlas 2-day event. But all that information is downloaded at the time, so you don't have to go and search for data on your local. It's down at the yes. It is a statewide coverage. If we go back, the problem, one of the issues that we have is this is all run on flood water surface elevation that we use for the floodplain. And we don't have full coverage yet. So these nice counties here that are empty, they're on their way. Well, we just don't have them yet. So we are limited in that bit of information there. Any other questions? Yes, ma'am. So the question was, I said that it was fairly accurate. How did we determine that? Well, the way that we determined that was using the thunderstorm Fred. We predicted that information, and you saw the high water marks that were there. Those were actually collected after the fact. So after Fred came blowing through, we had surveyors out there, and they were collecting high water marks. And then we put them on the map so that we could compare them to our boundaries. One of the problems with Fred was that there was a lot of flash flooding. And so there were high water marks that were, well outside of our inundation boundaries. And that was to be expected. Flash flooding is exceptionally difficult to predict and give any kind of accurate representation of where it's going to flood, mainly because they happen so fast and there's so many other determining factors. So we were concerned mostly with fluvial flooding, which is riverine. Now we do have a project called the 2D, Richard, help me out. 2D advisory flood that might help a little bit with that because it expands the inundation a little bit so that we can use that on top of and in addition to the fluvial information, but that is not available yet. Any other questions? Zach asked when the middle of the state was going to be available, and I say that is a very good question. I will get back to you. Yeah, for the middle of the state fest. Yeah, it's because you're missing here, right? A lot, according to Richard, a lot of it is in prelim now. So it's being prepped in prelim to be released late this year, early next year. You're welcome. Any other questions? Thank you.
Thank you, John.